What are the properties of exponents? This video is for task 2.8. Make sure that you go to the page of notes that has this video title up top. And this is the second video for the task 2.8. What are the properties of exponents? Okay, here's a reminder of how your notes should look like in order to take notes from this video. You should already have your notes set up from the previous video, which was for chapter 6, section 3 for tasks 2.8. And now this is the second video title. What are the properties of exponents? Here's a reminder of what a exponent is used for. It is usually used for a base. The base could be a number or a variable, and then the exponent is kind of the upper script, and that could be either a positive or negative integer. And remember that this entire thing is called a power because it's very powerful. It's not just multiplying by a simple number, it's multiplying by itself multiple times depending upon the exponent. Okay, so this is just a review of exponent properties. This is not to teach you exponent properties. I just want to point that out first because I'm going to go pretty fast and I'm just going to summarize these properties that you should have already discovered and learned about in previous years. So the first exponent property that we're looking at is anything to the 0 power is going to equal 1. Anything. So any number to the 0 power equals 1, and any exponent, or excuse me, any variable to the 0 power also equals 1. Okay, and here are some examples for you to write down in your notes. Okay, just a reminder, when you are reading math, here's a way to help you read it when there's something to the negative power. 2 to the negative 4 is read 2 to the negative 4th power. And we can never have a negative exponent, so we always have to make it positive. And here are some examples of negative exponents and their answers. And you're supposed to guess the property, but like I said, this is a review, so I'm going to let you know what the property is. If you have any number or any variable to the negative exponent power, you're just going to make that into a fraction. And you actually take this and put it in the denominator, and it makes it a positive n, or a positive exponent. If this was a negative n in a denominator, you would bring it up to be a numerator. So it works both ways. And this is just one way to show that if you have a negative exponent, you're going to make it into a fraction, and you're going to put it in the denominator. Okay, pause the video, take the time to write down these 4 examples, and then replay them when you're ready. Okay, I'll assume you paused the video and wrote down all 4 examples and their solutions. I would normally give you these problems, have you solve them, and then give you the solutions, but I'm told you that this is a quick review. So here are the answers for you. Let's go ahead and talk about them. Here's a negative exponent. You need to put it in the denominator, make it positive, then you expand it and get 1 to the over 64th power. Anything to the 0 power, whether it's a number or a variable, is just going to be 1. So that answer should be 1. Here we have a negative number raised to a negative power. Now, because the only thing to make positive is the power, is the exponent, we're just going to put that in the denominator, but keep the 5 that's in the parentheses negative. And if I write 4 negative 5s in the denominator, that gives me positive 625. And here's a different example. This negative does not belong with the exponent, so it really doesn't belong to the 5. You can actually take it out away from the 5 and then just put the positive 5 to the positive 4 in the denominator. Expand it, but because that negative wasn't in the parentheses like in part C, your answer will be negative, and it'll be on the outside as negative 1 all over 625. Okay, did that very quickly. Remember, this is just a review. Bring all your questions to class. Okay, let's quickly recap what we just learned. We learned that so if I have 0 to the negative x power, I would need to write that as 1 all over 0 to the x power. Anything that 0 to any power, will be 0. And we cannot have a 0 denominator, so this is going to be undefined. X to the 0 power is 1. X to the negative 2, remember, we make it into a fraction to put it in the denominator to make it a positive exponent. And when the negative exponent is in the denominator, we put it up top to the numerator to make it positive. So this becomes x to the squared power. Let's go ahead and apply what we just learned. We're going to evaluate the expression for the given values of the variables. Remember to pause and write down the example and then follow along when you're ready to listen to me. We're going to do negative 2 to a to the 0. A in this case is 5, so 5 to the 0 power. B is negative 3, and we're going to raise that to the negative 4th power. So I'm going to rewrite the negative 2 because it's fine. Remember, I got to do exponents first for order of operations. 5 to the 0 power is 1. And then I'm going to go ahead and evaluate this negative exponent negative 4, and that becomes 1 all over. Notice negative 3 is in the parentheses, so it stays within parentheses. And that's negative 3 to the positive 4th power. And then negative 2 times 1 is negative 2. Evaluate negative 3 to the 4th power, which is all over 1 to the 81 power. Excuse me, 1 over 81. Negative 3 to the 4th power. I write negative 3 4 times and multiply it by itself, and I would get 81. And it's positive. And then I'm going to multiply straight across here and here. So my answer becomes negative 2 all over 81. And that's as far as it can be reduced. Throughout the packet, you're going to be expected to simplify exponential equation or simplify exponential expressions completely. And in order to do that, there must be some rules you need to follow. First of all, you need to make sure that there are no negative exponents. Remember, all exponents must be positive. You got to make sure the same base does not appear more than once in a product or quotient. So that's product is when you multiply, quotient is when you divide. I can write that here. Multiply and divide. Make sure that you do not have the same base. There should be no powers raised to power, no products are raised to powers, no quotients are raised to powers. So no powers raised to powers, that means that you can simplify it further. No products are raised to powers, that means that you can simplify it further. And remember, this is using multiplication for products. No quotients are raised to powers. You can simplify that further still. And all constants are reduced and simplified. So we're going to look at some rules and examples of the properties of exponents and how to apply them. Okay, here are all the exponent properties. And this is really the meat of what we've been talking about for this video. So here are some rules. There are about 1, 2, 3, 4, 5, 6 different rules. And it really tells you when you have to do certain things to the exponents because they're all exponent properties. So you add the exponents when you multiply the bases. Notice that we're multiplying here, so we're going to add these two numbers, 7 and 4. So I get 6 to the 11th power. And I'm going to prove some of these in class the following day. So this is when you multiply, and I show my kids when you can circle the exponents is when you multiply them. So this becomes 6 to the 28th power. And that is because you're taking a power, which is 6 to the 7th, and you raise it to another power of 4. So you can simplify that by multiplying. And then when do you distribute the exponents? Well, here I have a product within a parentheses. I'm going to distribute the 3 to the 2 and to the 4, and then I can simplify. So it's 2 to the 3 times 4 to the 3. And that's the same thing as saying 8 to the 3rd power. Okay, also when you apply how do you apply this exponent to a fraction? This is a quotient, so you can simplify it further. The 4 will go to the 3 and to the 5, so this becomes 3 to the 4th over 5 to the 4th. For number 5, how do you apply the exponents when it's a negative instead of a positive? Well, because it's negative on the outside, I'm going to flip the inside and make it 5 over 3. The 4 becomes positive, and then I distribute just like I did for number 4. And I get 5 to the 4th all over 3 to the 4th. And the last part is when do you subtract the exponents? Here I have 7 and 4. I'm going to subtract those since I have the two bases being divided. It becomes 6 to the 7 minus 4, which is just 6 to the 3rd power. All right, those are the 6 exponent properties. This would normally span over 4 or 5 different videos, but I had to condense it into one for the new module packet that we're working with. And now for the next 4 slides or 5 slides, I'm going to practice some of these properties with you. Okay, take a minute, write down everything on this slide, and then try to solve some of the problems. What do you think we do to the exponents here? Should we add, multiply, divide them, subtract them? What do you think is the best to do? And look at the properties from the previous slide. Okay, hopefully you practice these on your own. And now here are the answers. Let's take a look. What did we do to the exponents? Well, your answer should have been add. We should have been adding all these exponents. So let's take a look to see what we have. I add 2 and 5 got 7. Remember that they must have the same base to add the exponents to simplify them. So I look at the cube bases. They have the exponents of 3 and 6, so I add and get 9. R is the only R squared here, so I just rewrite it. For this one, I have the 2's are the same bases, so I add those exponents and get 2 squared. Then the 3 are the same bases, so I add the exponents and get 3 to the 6. And here, they're all the same base of n, but the exponents are a little funky. This one is missing 1, and so what's there? An invisible 1. So I'm going to add up all of the exponents. I get into the 0, and I can go further, and into the 0 would be 1 power. Okay, hopefully you got the correct answer. If you didn't, then go ahead and retry these examples. Okay, here are 4 more examples. What do you think we do to these problems, or these exponents? What do we think that we add them, subtract them, multiply them, divide them? What do you think is the best plan of action for these which properties should we apply? Go ahead and look back at the list of properties for exponents and see if you can figure it out, and go ahead and write your answers. When you're ready to resume, then push play and follow along with me. Okay, so here are the answers. Hopefully you noticed that you had to do a few things with these exponents. The first thing that we had to do was multiply these exponents. That was the big property that we applied. And then some of these you had to end up adding. And then really you end up having to simplify the rest. Okay, we didn't have to subtract any. But let's see how we had to use all of these properties. Here you can circle the exponents, so we multiply them. We got 5 to the 8th. I could circle these exponents, and I got x to the negative 15th. Then I noticed that I couldn't circle these exponents so easily, so that's when I add, and I got x to the negative 11th. And then I realized that I can't have a negative exponent, so I made it positive by putting it down in the denominator. For part B, I multiplied and got, since I could circle the exponents, and got 0, and 4 to the 0 is 1. And then for part D, I could circle these exponents, and I got a to the 12th. Then I circled these exponents, I got a to the positive 6th power, because negative times negative is positive. And then I realized that I can't easily circle the exponents, so this is where I add, and that is the farthest I can go with this problem. Bring your questions to class. Let's practice a few more examples. Okay, here's just some extra exponents to simplify. We're going to have to apply a lot of the new properties that we just learned. So go ahead and attempt these problems. Try them out. Remember, you learn from your mistakes. And then play the video when you're ready to see the answers and follow along with me. Okay, here are the answers. Let's go ahead and check them, see if you got them correct. This is where we're going to have to distribute a lot on this slide. We had to distribute a lot of the exponents because of the parentheses. The parentheses tell us to do a lot. And so here this is telling us to distribute the exponents. For part A, we distribute the 2 to the 2 and the y. I just rewrote the negative because it was on the outside of the parentheses. So, and then I simplified. 2 squared is 4, and then y squared is y to the squared power. And since it's all a product, I just rewrote it as negative 4y squared. Here I had to do a few properties. I had to first distribute the 2 to go with the 6, and then distribute the 2 to go with negative 3. And then if you know the trick, you don't have to show this step, but you probably don't, so I showed the step for you. I can circle the exponents, and that's when I multiply, and I could see that here, that I would just multiply and multiply, but some people forget, so I just wrote that step for you in. And then I multiply, I get x to the 8th, and then y to the negative 6th power, but I can't have a negative exponent, so I bring it down below. Now my exponent's positive 6, and I'm happy. And I just want to check, these are not the same bases. This is x and this is y. They're different variables, so I can't simplify further. This is my final answer. For part B, I distribute the 3 to the negative 2, since the negative's on the inside of parentheses, and the 3 to the y. I get negative 2 to the third, y to the third. I simplify and get negative 8. And then y to the third just becomes y to the third. And this is all a product, just like part A. And I just rewrite my answer as negative 8 y to the third power. Okay, here are 2 other examples. Part B is a little bit difficult, but go ahead and see what properties you would apply to these exponents. Okay, here are the solutions. Let's go ahead and check to see if you're correct. You're going to just distribute this 2 to the 4 and to the 7. We got 4 squared over 7 squared. Really simple exponent, so I simplified it further and got 16 over 49. Now I'm done. Here, this one is a little bit difficult because I had to distribute this exponent down here and then distribute this one for the bottom one only. So I first distribute this to the top, and I got 2 squared and then 2 to the x to the third. And then I distribute the 3 to the x and y, and then didn't forget about that extra 2 because remember that 2 also comes down to the denominator. So I got to distribute the 2 here and here. So now I simplified. 2 squared is 4. X to the third to the squared power is x to the 6. X to the third to the squared power is x to the 6. And y to the third to the squared power is y to the 6th power. Notice that I was multiplying here. Then I realized that I must have the same exponents, same base. And I notice I have the same base here and here. So that means I can simplify further. Since I have the same thing on top with the same thing on bottom, they reduce to 1. So now I just have 4 times 1, which is 4. And then y to the 6th for the denominator. And that's my final answer. Okay, let's do one more slide with a few more examples to practice our exponent properties. Okay, can you guess which properties we're going to use for these 4 examples? Think about the last one we haven't used yet and try to apply it to these problems. And when you're ready to follow along, go ahead and resume to see the solutions. And we'll discuss them. Okay, now let's go and check your solutions. We have 2 to the 9 over 7. What is the major property we're using here? Is subtraction of the exponents. This is where we're going to have to subtraction. Okay, there we go. This is where we're subtracting the exponents. So for the first part A, 2 over 9, 2 over 7. 9 minus 7 is 2. 2 squared is 4, but I didn't go further. We should. It's very simple. Here I had to distribute the 2 first, and then I realized, oh, I got to subtract the exponents since I have the same base. So the 4 minus 2 for D is just D squared, and then the 3 minus 2 is 1, so it's just E. Here I subtract 1 minus 4 and got negative 3. Then I realized I can't have a negative exponent, so I put in the denominator for a positive exponent. And then here I can only simplify the same bases. So the red, which is the 3, I get 3 to negative 1. The blue for the 4, 3 minus 4 is negative 1. And then the black is for the 5, which is 5 minus 3 is 2. And notice I have 2 negative exponents, so both 3 and 4 belong to the denominator to make them positive ones, and I didn't need to write them. And then 5 squared stays in the numerator. And then I simplified further because it was simple, and I got 25 over 12 as my final answer. Okay, so we just reviewed all exponent properties. I told you this is like 3 sections of a chapter and 1 video, so it's pretty lengthy. But go ahead and write down all your notes. Go back through, re-watch the video, get any last details that you might be missing, and practice these examples because we're going to be practicing them over the next couple of months in class. Okay, see you later.